Good morning, everyone. So how did the homework go? Any questions about the homework? As usual, put them on the chat or unmute yourself and let me know. Okay, if I don't get anything, it means you did the homework and you didn't have any difficulties with. So I will proceed. So it's your chance to let me know. Okay. All right, I'll give you 30 more seconds chance to ask your questions. Okay. All right, so if you guys are comfortable with the homework, what we are going to do today is we are still in section 1.2, still with function. And the goal of this section is to remind you basically about some fact that you know, but I would like to remind you of. So the idea is today what we call it transformation of functions. What do we mean by that? Let us say you have a function f of x. So you have a function f of x, you know it. And then you take a new function, I call it new, which is, sorry, I think I should use another pencil, which is f at, let us say, x, but you add a 2 to it. Okay, so you have a function f, then you create a new one, which is f of x plus 2. And the simple question is, what's the relationship between the graph of f and the graph of g? Basically, how do we get g from the graph of f? Okay, so I'm sure all of you have seen this, but let us a little bit remind ourselves of all those transformations. So this is, let us say this is f. Just draw anything. This is my f. Okay, what is my g? What does g do? For every input, x, g is whatever f take, that's f, but you add 2 to it, means you push it this by 2 units. Okay, so that's what g does. So whatever f does, you add 2 units. Whatever f does, you add 2 units. Whatever f does, you add 2 units. So the graph of g is not going to be nothing more than the graph of f shifted vertically by 2 units. So that's the first transformation we see. So first transformation is the following. So I'm summarizing them here. So suppose we have the graph of f. Suppose c is a positive number. To obtain the graph of f of x plus c, simply shift the graph of f c unit upward. If you take minus c, naturally, you're going to shift the graph of f c unit downward. Okay. Now, I'm going to take another transformation. I will talk a little bit about it and then we read what it does slowly. Suppose now I take the following function. So I have f, that's my old. F is the old function. And now I'm going to create a new function. I'm going to call it, let g of x be what f does, but not at x. What f does at x minus 2. So g will do to x what f does not to x minus 2. So the output at x for g is the output of f at x minus 2. Also, very simply, graphically, what is this going on? So this is the graph of f. So let us say this is f, go like that, like this. Okay, so this is my f. What does g do? So this is 0. Suppose I take 2 here. what does my new function g, what does g takes 2 to where? Can anybody answer my question? Yeah,
Down.
absolutely correct. It takes 2 to the right. I know that definitely. But I want g of 2. You're absolutely right. All of you are right. I want g of 2 though. I totally agree with you, and that's what we're gonna say, but I still I'm gonna ask you, what's g of 2?
0.
0, right, because g of 2 is what f does to what? To 2 minus 2. That's what g of 2 does. So it's f of 2 minus 2. So g does to 2 what f does to 0. So what is the value of g at 2? The value of g at 2 is actually 0. So what f does to 0, g is going to do it to 2. That's really where the idea of a shift is really coming from. So for example, if I want to know what does g do to 3, so what's the output of g at 3? G will take at 3 where f exactly took at 1. That's really what's happening. So whatever the value of f at 1, so if this is 1, whatever f takes at 1, g is going to take it at 3. That's the idea of where this shift is really coming from. And whatever f take at minus 1, g will take it at minus 1. G would take it at 1. So the graph of my new function is going to be the old function shifted by 2 units. And it is shifted to the right. Okay, so because what f does at x, what g does at x, what f does at x minus 2. Whatever g do at 3 will go back to f. What does f do at 1? That's the value of g at 3. So the second transformation that we do is the following. G of x, if f of x minus c, what's its effect? It shifts the graph of f c unit to the right. That's what f does. If you take f of x plus c, it's also a shift. I may say horizontal shift because I'm changing the input here. It's the shift, the graph of f c unit to the left. So those are the very basic transformation. Okay. Now we're going to see, oh, sorry, I did this right twice. Forget. Now, one more transformation that I think those are the basic ones. So one more transformation is the following. Suppose I have a function f and I create a new function. And this new function does the following. Whatever f takes, times it by 2. So it multiplies f by a constant 2. So what is the effect? So, okay. Now I know a lot of you, most of you should know the answers to that. I'm not really. So suppose this is my f, my original function. And I don't know, this is a bunch of numbers. So this is my f. So what does g do? What g does to an input is the following. It takes what f does, times it by 2. Okay, so let's see the effect. Let me give those names. So let me call, numbers, minus 1, 1. So now very questions like I did before. What does g of minus 1 equal? But I'm gonna graph g intuitively. What's g of minus 1? Okay, it's twice 2 times what f take at minus 1. Now, f is 0. When you times by 0, it stays 0. So g, when f is 0, g will be 0 because we times it by 2. At 1, again, it's going to be 0. Now let me call this, let me give this a number, for example. Let me do that like minus 3. Now what's g at minus 3? What does g do to minus 3? Okay, I want a quick answer on chat. It's minus 6. So this is minus 3. What's a g? it takes twice. Whatever f does, it multiplies it by 2. Sorry. By 2. My apology, that's not what I want. My apology. What's g at 0? Sorry. What's g at 0? It's whatever f does at 0 times it by 2. Okay, what does f2 add to 0? -3. So whatever g does at 0, multiplied by -2. So my new function will take this value. And now the whole thing. Whatever f takes by that, what g is going to do is stretch it by 2. Whatever it does here is stretch it. It's stretching it this time because it's multiplying by 2. And then it's stretch it. Whatever g does is stretch it by 2. So my g at 0 is the same thing as the graph. Everything else is being stretched. At -6, and it's gonna stretch it like that. So this is twice f of x. So we multiply, when we multiply f by a constant c, and if the constant is positive, the effect on the graph is actually nothing more than a stretching by a factor of 2. All right, the other transformation, that what if I take the constant, so let me create a new function h, and instead of taking 2, I take a half. So that's a new function. So it's half the original function. So what's going to happen this time? Now, what's the fact that the importance of a half?
Make it wider.
Make it wider. So let us see what it does. H at -1, f is 0, h will stay 0. At 1, f is 0, h will stay 0. What about at 0? What's gonna do? F takes -3. H is half of that. So -3 half is gonna go right there. If I take a point, any point, F, if I take, let us say this is a point, let us see that 3/4. F takes to here. What H is going to be is taking half of this. So it's gonna basically half it. So now, if I take a point right there, here, this is the value of f. What's the value of g? Half that amount. So half that amount, half that amount, half that amount. Whatever f does, here, g is right, h is right there. So the graph is going to be exactly like this. That's going to be the graph of So if you multiply f by a constant, which is bigger than 1, the effect is to stretch vertically by a factor of c. If you multiply f by a factor less than 1, it's basically shrink it by a factor of c. So this is the, basically that's the summary of what's really happening. If g is a constant times f, while c is bigger than 1, the effect is to stretch the graph by a factor of c. Imagine you have a rubber band and you are stretching it. If c is less than 1, but always positive, it compresses the graph of f vertically by a factor of c. Finally, the last transformation that will be of interest. Suppose I have a function f of x, and I create a new one, which is take for every input x, the output of the new function is minus the output of f. And then the effect of that is just to take the graph of f and reflect it across the x-axis. So those are the basic transformation that there are more, but these are the ones that I really care about in this our class now. So these are the effect of the transformation on a graph. So let us see a little bit why we care about that a little bit. I mean, there is a reason, of course, we care about that. Because something simple. Suppose I know the following graph. Suppose there are some graphs that we actually should know how they look like. And I will tell you very soon which graph I want you to know how they look like, because we will be using them continuously. So suppose I know the graph of the square root of x. And the graph of the square root of x, so at 0, it's 0. And the function actually keeps increasing and going like that. So that's the graph of the square root of x. And we know the domain here, the domain is x positive, and that's why there is no output in here. So this is a simple graph. So let us say you encounter the functions, the square root of x minus 4. Okay, very simple stuff. And then you don't really need a calculator to be able to know how the graph looks like. We should know the relationship between them. So what's the graph of g of x? So g of x is nothing basically more than f at x minus 4. So how do I get the graph of g? It's basically we take the graph of f, since I put a minus 4, and we have to shift it by 4. So we're going to start right there and shift it by 4. So that's the graph of my g of x. And it makes sense in terms of the domain, because my new function, its domain is, we need x minus 4 positive. It means x bigger or equal to 4. So that's why also the domain fit, because the function here makes sense only for x bigger than 4. Okay. So sorry. I will take one more example. And again, it's a simple example here. Suppose I take the following example. And let us say I tell you sketch the following graph. So this is my function f, the one you see. And let us say, for example, sketch the graph of the function f of x equal, let's make up something. Let me see, this is f. I want the graph of g of x, which is equal to the following. So f of x is, let me erase that, f at x, and let me add plus 3. Okay, that's my new function. And the question is simply sketch g. Is this an easy or a hard question? Okay. How do we get f from g? We have to shift, because I have x plus 3 here, shift to the left by 3 units. That's the effect. All right, so let us construct g. So whatever f does, we're going to shift to the left by 3 units. So what happened at 3, this is going to be shifted here. This is my 3, that's minus 3, because we're shifting to the left. This will go here. This point, because this is 6 in my picture, I shifted to the left. This will go right there. So now my function g would look exactly like f, but just shifted. It go like that and like this. That's the shift, kind of. Okay. Now we're gonna just play a little bit with this function. Now suppose I construct h, and my h is, let us say, 2 times f of x plus 3. This is my h. So let us construct h. So what is h? We start with f. We shift it to the left. After we shift it to the left, we stretch it by a factor of 2. So we shift to the left, and then we stretch by a factor of 2. So that's exactly what I will be doing. So I've already shifted to the left, and then I need to stretch it. So how do we stretch it? 0, nothing happened. Every value will have to be stretched by a factor of 2. So this will be right there. If the function f takes the value 1, my new function, when we stretch it by a factor of 2, is going to be 2 right there. 0 will not change. That will stay where it is. What about this one? This has to be stretched by a factor of 2. So if I go right here, this is minus 2. So my new function would be the old function shifted and finally stretch. So that's would be my new function h of x. So this is my h. Okay. Now I can keep having variation of that. I can keep having variation. So let me do one more variation. So suppose I create the following function. So this is h. Let me call it L. L of x is the following. 2 times f of x plus 3 plus 1, for example. Okay, so we're building on it. So how do I sketch L? All right. I first start with f. Starting with f, we shift it. So that's the first operation. After reshifting f, we basically stretch it by a factor of 2. I already have h. After I do all this, then I add the 1 to the result, which is really nothing more than an upward shift. So let's see L. So F, shift it, stretch it, and now absolutely nothing more than an upward shift. So the 0 will go to 1 right there. The 2, we're going just to shift this, so this is going to go to 3. So I'm right here now. And then the minus 2. The minus 2 is going to go up to 0. So it's going to back up to, sorry, the minus 2, we're going to add 1. So it's going to go right there. So now this is my new graph. The old one shifted by a factor of, and this is my function L of x. Okay, so these are the idea of shift that I'm sure that most of you are familiar with, but it's quite a review for that. Okay, today I stop right at this stage, and right now you guys will have to start the quiz. So I will guide you through how you do it, and then you get started. All right, any questions? All right. So make sure you have a nice piece of sheet of paper in front of you, and you guys, if you're not on Brightspace, please log into Brightspace, and I'm gonna share the screen with you to tell you where everything is. So, sorry, I'm here. Okay, so that should be Brightspace. I will go to what I think that's the student view. So that's what I think you guys see. You have a sheet of paper in front of you, all of you. Okay, go to content on Brightspace, all of you. And then go to quizzes. Are you with me? Go to quizzes. Click on quiz. Click quiz 1, PDF. The quiz is in front of you. You get started. You take the quiz on a nice sheet of paper, writing very clear, and do the problems in order. So the problem should not really take more than 15 minutes at all. Now, once you are done with that, you need to upload it back in. So once you're done, you go down here, you upload. The minute you upload, then you hit the submit button. All right, so that's how you take it. If you have any questions, you use chat privately. I'm with you, and I will take any questions.
I have a class starting at 9.
The quiz should not take more than 15 minutes.
All right.
Okay, and if you really didn't finish, you have difficulty, you let me know. Okay, I will accommodate you very much today. Is that clear? Every one of you will have all the time you need today.
I have a question.
Yes.
Should we have a graph sheet of paper with us, or are there?
No, you don't need in this exam. No,
okay.
Sorry, I meant in this quiz. Any other questions? Okay.
Wait, so we show our work on a piece of paper, then upload a picture of it?
Exactly. Exactly. So it should not take a lot of time. As I said, if you really bogged down, don't worry about it. I will give you all the time you need. Is that very clear? I wanted to get used to the system because that's how we will be doing things.